Okay, today we're going to look at complex numbers and de Moivre's theorem, and we're going to apply that to the following problem. Prove that sine pi theta equals sine theta 16 cos to the power 4 theta minus 12 cos square theta plus 1. So how do we wish to do that? Well, first of all, let's consider what a complex number is, just a little bit of a recap. We have our x-axis is now equivalent to a instead of the letter x, and it is considered the real axis there instead. And the y-axis, or what is normally called the y-axis, is now going to be called b. It's now going to be called b, and it is considered imaginary. It is the imaginary values. And when we say imaginary, we use the letter I, the fact that I is the square root of minus 1. And so I squared would be equivalently minus 1 because of the squaring of both sides. Now, in these circumstances, you could try and utilize double angle formulae from the very beginning. You could try that. The double angle formulae you would need are these two. However, the problem with doing that is that it can become quite cumbersome very quickly. And I would suggest perhaps having a go so that you can see the degree to which you might have a more elegant solution if you were to utilize complex numbers. We are going to utilize these. We're going to utilize them, but what we'll do is we'll do them in the context of complex numbers and hopefully solve this quite comfortably. So what do we mean? Well, this axis here, have far too much purple. This axis here has been simplified from this one, so it's not as much information on one diagram. We've got our A and our IB, multiples of the imaginary number. Now, in these circumstances, you can see I've moved 1, 2, 3, 4 steps to the right, so I'd say 4 along the A, and in order to get to this point, I'd have to move 4 steps up, so I'm saying 4i. Additionally, please be aware that the length, we can instead use Pythagoras' theorem for that length, and we can say that this length here, will be a squared, therefore this length here will be b squared, and then finally the length that we might want to know at some point later, that length could be said to be a squared plus b squared square root. Now, therefore, you could apply that here and suggest that it's a squared plus ib squared. However, that's not always needed to be the case, because we know that this is a representation of the number of movements along the y-axis direction, or vertically. So you can simply just utilize the value b, the 4 in this example, b squared, and so a squared plus b squared will give you this length here once square rooted. Now, here's an example of the triangle that we're dealing with. So we have this here, and you can see very quickly we can utilize trigonometry, and we do. We have cos theta is equal to the adjacent side, this side at the bottom, of course, divided by the hypotenuse, which is r, that length r, and this can be utilized when writing this equation here. Instead of writing a plus ib, we can write r cos theta plus I r sine theta.